The broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone, to our Supply Chain Council conference, or webinar conference for today. We have a lot of people coming online from all over the world. So we have a lot of different transmission speeds. I wanted to welcome with us today Sean Culey. He's based in the UK. He is overseeing our leadership team for Supply Chain Council in Europe, and just presented this session at our Europe conference a few weeks ago in Frankfurt, which was very well received, and so we are holding it today as a webinar so that more people can view it. There may be a couple of things in here since we are transmitting with a lot of video. All parts of the world. We have some bits of lag in here because it's a very video-rich presentation. So there will be a few spots where maybe the people's mouths aren't keeping up with this little thing. We think we've got it so that you can understand the presentation and see what Sean has. I am recording this, so we will have this available afterwards as a YouTube video. Also, if you have questions, please ask them in the question box at the bottom. And I'm not sure why we have a bing every time somebody comes on today, because that didn't happen before. But I'll see if I can turn that sound off once we get started. In any case, go ahead and send me questions in the question box. And anytime during the webinar, and we will ask Sean questions afterwards, if you like, after the webinar is finished. If there are things that I can answer during the webinar, I will do that, answer your questions while we're live. So, Sean, did I leave out anything? I think we're...
No, I don't think so, Melinda.
Welcome, Sean. Thank you.
Thanks very much. I hope everyone can hear me clearly, and thank you to everyone who's joined. A little bit of background first, if I may. This particular webinar I've developed following an article I wrote last year, which in itself was written after attending a couple of conferences where a number of independently interesting and innovative developments were discussed. And the thing that came to mind to me was really what happens when you start to join these things together, as they will inevitably do to the end-to-end supply chain, and therefore all the stakeholders and all the actors involved in the supply chain. And I wrote an article for the European Business Review on this, which was well received, and that's led to the production of this particular webinar, which I've delivered a couple of times now. It's more of information. It's I hope you find it interesting. I usually say, I've got much aspiration of what I'm trying to achieve in the next hour, but we're going to start by going back in time and looking at the development of the supply chain and the impact that's had on the working environment of people. Then we're going to look across the end-to-end supply chain. We're going to travel around the world, and finally we're going to go into the future. So got a bit of aspiration to where we're going to go in the next hour. I hope you find this informative and thought-provoking. And with no further ado, I'd like to start by going back in time. So let's take a brief journey through history. Where are we now, and what do we have to go through to get here? So we start off with supply chain 1.0, which really started around the industrial age. If we look at where we've come from, originally back in sort of the 1760s to the 1840s, specifically out of the United Kingdom, the first industrial revolution took place. And here we're looking at, a dramatic change in the nature of work, where people had to move out of the agricultural industries, which had been very similar for, hundreds of years previously. And, new levels of efficiency were created through mechanized cotton spinning, through development of the power loom, which increased worker output by a factor of 40, new developments such as the cotton gin, and the introduction of steam power as well, and the efficiency that steam engines brought. And this, this greatly increased the amount of efficiency that, one particular person could generate through the use of automation. It also created completely new jobs and changed the face of the workplace. Moving on from that, we then went to the second industrial revolution from 1860 to 1914, or sometimes been called the age of synergy. Again, new innovations arrived at this point in time. So we had the introduction of the Bessemer process, which introduced mass production steel from molten pig iron. We had the concept of interchangeable parts. The start of the introduction of electrification, allowing for major developments in manufacturing. But also something really interesting here, and the work of Frederick Winslow Taylor and the movement of Taylorism, which when he wrote his book, The Theory of Scientific Management, we started to talk about management and the need to manage people differently. And this is something that didn't really have to do in the past. Everyone knew their jobs. Everyone knew when the seeds need to be laid. Everyone knew when the harvest needs to be collected. You have to manage the activities of people. And this is where management really started to come to its own. So we have new jobs, new roles now, again being arisen as a result of automation. Then we had the introduction of the assembly line coming out of the first automation revolution in about 1913, which in itself was based off the disassembly line, basically looking at the abattoirs and the production process or the deproduction process that took place there, and it created the first automation revolution, the Model T Ford, and all the efficiencies that were created out of being able to produce things in a continuous process. And then we got really good at that. So Japanese car manufacturers, take that process and created new levels of efficiency and created new levels of business culture and principles like Kaizen and Lean and total quality management and total productive management, started to arise and created new levels of efficiency. But it also created a performance goal. And has been well documented, and between the performance goal of efficiencies generated by the Japanese car manufacturers when compared to, for example, the American car manufacturers, and the American car manufacturers trying to play catch up and trying to introduce these processes, these ways of working in order to achieve these same levels of efficiency. Moving forward in time again, then supply chain 2.0 could be said to be the computer age. Now this is where we start to rethink the way we do business. So this is a change in thinking as much as it is a change in technology. So we're now talking about principles like MRP, MRP2, and the introduction of things around sales and operations planning. Michael Porter starts to talk about value chains. The concept of supply chains and value chains get introduced. The alignment of activities to strategy becomes important. But also from a technical perspective, the development of the computers as something that can be introduced into the workplace and automate the office environment, as well as being a sort of backroom activity just for a heavy processing of a mathematical equation. This is, again, changing the nature of work, changing the level of efficiencies that people can actually create in the workplace. And also, obviously, create new jobs. Moving forward to the 1990s, and people like Hammer and Champy producing materials around re-engineering corporation, and people realizing that we need to rethink the way we do business. And this goes again hand in hand with technology, the introduction of ERP systems like SAP and other systems like Oracle, PeopleSoft, SAS, the other ERP systems that were around at the time, enabling the integration of these different functions in the organization together so that we can integrate financial information with sales and distribution information, and we can start to see a sort of single version of the truth. Of course, come the 2000s, and we had the dot-com boom, and again, we had pieces of work from theories and beliefs, Thomas Friedman's The World is Flat, looking at the impact of globalization, the World Wide Web, allowing people to trade across previous geographic borders, changing the nature of work, people moving towards offshoring, moving manufacturing away from being just around where the customer is to being around predominantly where it can be sourced at a lower cost, changing the nature of management tools that are required, the skills, the capabilities. The whole nature of work is being changed by a change in technology, but also a change in thought process. And that leads us now to 2013. So where are we now? Well, right now we're looking at a situation that looks a little bit like this. We have satellites moving around, we've got visibility, we've got stuff moving all over the world, we've got ships sailing, we've got offshoring from far afield, we've got consumers, demanding ever-changing products, and we've got a very complex supply chain model. This hasn't come about cost. So if we look at the end-to-end supply chain, and I'm using the Supply Chain Council score model as my reference here, so source, make, deliver, return, plan. We look at what's actually going on in the global supply chain right now. What's the cost of all of this globalization? Well, if we look at source, so we're actually sourcing raw materials and raw components, we're still hearing tales of children working, and child labor, things that have been eradicated, we'd like to think, certainly from the more Western environments some years ago. We've got lots of migrant laborers still using their hands to pick stuff out of the ground. We've still got people digging stuff out of the land and mining conditions that are, wouldn't be accepted, for example, in the UK or the US or other countries, but are still, acceptable in those emerging countries, and creating headlines that like this that, aren't particularly nice to see. Then we have to move stuff around the world. So this has created an increase in air freight and sea freight. And there's been lots of headlines, especially recently, about this increase in movement of goods has to some extent commoditized the movement, and therefore has to work harder, fly longer. And there was a lot of issues recently, and this could only have come from from England, where pilots were asleep, effectively both pilot and co-pilot were asleep up until 3 minutes before the plane landed, and their statement, "Crikey, that wasn't good," being very English response to the fact that they just averted a disaster. But it wasn't alone, and pilots and people are sort of reacting to this and saying, we have a problem here. You're putting us under more and more pressure as people to be able to move these goods and move these people with increased levels of frequency. When we go to manufacturers, we go to the make process. Again, there's tales of real issues and headlines have been created. So you will remember on the 24th of April this year that the building collapsed in Bangladesh, where 1,129 people died, but there was another 2,500 people injured. So you're looking at over 3,500 people effectively working in one building to create what was low-cost clothes. And people see these headlines and they see these images, it doesn't sit very well, and it potentially creates brand, but also it asks the consumer to ask real questions of themselves. We like low-cost clothes, we like low-cost electronics, but what's the human cost of producing these? Over in China, in the manufacturing processes, there's been particular bad press, specifically around what's been going on in countries like Brazil. So the conditions out in the Amazon, working conditions for people who are making Samsung products. Over in the electronics industry with Apple, headlines like this, are particularly unwelcome. The working environments that exist in Foxconn, the 17 suicides that were caused because of the working conditions, and this is going back to that sort of Tayloristic management model that we saw that had arrived at the end of the 19th century, still being used very much where we're putting a person in a role, and to some extent, headlines are saying we're dehumanizing the working environment, and headlines like this, don't sit well when they're broadcast across the world. And it's not just, electronics, it's also clothing and apparel and other industries, that get these sort of bad press because of these dehumanized working progresses. So you could ask yourself the question, when you look at these two pictures that are 100 years apart, have we made real progress? The two pictures look very, very similar. Now, we've made products, we've sourced raw materials, and we've made products. Now we need to get them to the consumer. First thing we need to store them, and you will see that again, looking over from the Seattle Times. So in America, we've got headlines around Amazon, the warehousing activities that go on at Amazon, pushing workers to their physical limits. In Germany, the same sort of headlines, probing Amazon warehouse conditions after film, and strike action that's taking place because of it. Over in the UK, same sort of headlines, treating humans like robots. They trek 15 miles a day around the warehouse, every move dictated. This is the future of the British workplace. So again, that headline, we're treating humans like robots. Movement of goods. Major issue with moving goods on roads, creating an increase in freight and the transit and the freight in order to move goods to be more responsive. The major issue could cause accidents, it cause major congestion issues, and obviously, fatalities is human error. People falling asleep at the wheel. So looking at these all independent across source and make and deliver and all of these issues that are arising that are causing a very human impact on the supply chain, what's the solution? Well, the solution is that we're now, in the solution in many companies' eyes, is we're now approaching supply chain 3.0, what I call the second automation revolution or the robotic age. And I'd like to now move forward and have a look at what's going on right now across the world in terms of the developments that are taking place that are going to change the complete nature of the workforce and the performance of the end-to-end supply chain through the use of automation. So going back to our plan, source, make, deliver, return, end-to-end supply chain from customer to supplier, supplier, let's see how automation is changing the nature of that supply chain. We'll start with source and supplier, supplier. So let's go first to the US. Here we're finding that robots, which has been used in the agricultural industry for a number of years now. We've got automated combine harvesters that are picking up wheat and being used on the farms. But now we're seeing something new arrive, and this is the development of robotics to work on fruit and vegetables such as lettuces, grapes, and strawberries. And the interesting thing about these particular vegetables and fruit is, they're particularly fragile. So these are the kind of things that it was always assumed human hands would have to be involved, and these are also the things that large swathes of migrant laborers are used in order to pick these particular fruits and vegetables from the land. So let's see what's happening there.
About Mother's Bot is that it in a field, and the time it takes about 20 minutes to do the job by hand.
Sean, we can't hear that very well.
Develop robots to do the most tedious, take repetitive tasks that are just and do it effectively, accurately. These engineers are teaching the machine how to recognize lettuce. We're also plans to develop robots for weeding and harvesting crops. We are one more step in farming, now riding on the wheels of robots. Terry Che, Associated Press, Salinas, California.
I hope you heard that okay.
Steve, tell us a bit about what that said, because we couldn't hear it.
You couldn't hear it at all?
Oh, it was just kind of bits and pieces.
Okay. That was basically what was going on there was the use of, and I'll come off the screen, it's telling me I need an injury lawyer. Basically what's happening is the robotics now being used in the farm in order to establish the quality of the lettuce buds and other such fruit, and to basically to reduce and eliminate those vegetables which he feels are not going to make it, was using squirts of fertilizer. But also what's going on is actually they've got machinery now that will pick and load all of these fruits and vegetables because of the increasing labor costs, and basically it's taking labor out of the equation. So the end line of that particular video was that the future of farming lies completely with robotics. They are developing more and more ways to completely eliminate all of the manual tasks involved in both, seeding, growing, maintaining, and picking fruit and vegetables. So that's, that's reduced an impact on the amount of migrant labor that's actually required. Let's now go over to Australia. Now this is a control center that's in Perth. And this is controlling a Rio Tinto mine that's 1,500 kilometers away in Western Australia. The thing about this is the operator in Perth who's controlling it has never been to that mine. So this mine is now completely automated. Previously, these were the most expensive mine workers in the world, and even the train drivers who moved stuff from this remote location in the middle of Australia over to the coasts where it could be actually shipped were paid about the same on equivalent status to heart surgeons in the US. So these were incredibly well-paid people doing very dangerous and very isolated roles, digging stuff out of the ground. So we saw the headlines earlier about Tanzanian workers digging their own graves. So what's happening here is that Rio Tinto has invested heavily in completely automating these mines where we have diggers, trucks, and now actually trains that are completely automated and completely driverless. And the workers and the unions have given up effectively trying to take any sort of action to prevent this progression, and are now using calls for community and the culture to try and hang on to what little jobs there are actually left. But they're effectively now in a world where people are not needed in that particular supply chain and that element of the supply chain to actually dig the raw materials out of the ground and actually move them to a location where they can be shipped. But we've got to fly stuff still.
Boeing test pilot Jason Clements goes through final flight checks in the cockpit of an F-16.
Let's make sure my switches are set in the right position.
Before takeoff, with the engines whining and a cockpit cooling system blowing at its max, Clements exits the cockpit. He then closes the canopy via a remote switch. In a matter of seconds, the aircraft, with its burner lid, roars into the southern sky, headed out. While in the air, the unmanned QF-15 reaches an altitude of 40,000 feet, a speed of Mach 1.47, and engages in aerial maneuvers such as a barrel roll while pulling more than 7 Gs. F-16 and F-4 chase planes off the port side follow the QF-16 as it makes its final approach back to Tyndall and picture-perfect landing.
Muted.
Hello, Melinda.
Oh, go ahead. Yeah, there was
Sorry,
something. Somehow, yeah, go ahead. I think we can hear everything. Yeah.
Okay, cool. Did that come across okay?
Yeah, that one we could hear. Just somehow we got muted.
Oh yeah.
Video.
I was
with
horror. I just saw it said I was muted, so I didn't. I hope you heard that. Basically, what was happening there was we saw earlier with the movement of goods that we had lots of issues with the human factor play where pilots are being overworked and falling asleep. What you just saw was an F-16 fighter that had been this was the back end of September, so it's very recent. It's been completely retrofitted and is now effectively completely automated. So it took off, did some very sophisticated maneuvers, and actually landed again. Now, what they're asking F-16 fighters to do in terms of the sort of G-forces they need to pull are completely different to what's needed in order to move goods around the world. So this is a really significant improvement because previously we have seen autonomous drones and flying around, but this is a retrofit to existing vehicles, to existing planes, and the ability for them to actually take off, fly and land all on their own, controlled remotely. So you get to see where are we going with this? What is the future of flight travel? Well, it's potentially in the situation where we don't need pilots, certainly not ones that are in the plane. Let's look at manufacturing. So what's happening in manufacturing? Now, robotics have been in the factory for some time, but they've always been big, and they've been single use, and they've been dangerous, and have to be surrounded by cages. Last year, the gentleman at the bottom there, Rodney Brooks, a robot called Baxter, and what you're seeing there is images of Baxter. So what I'd like you to do now is I'd like you to meet Baxter.
Meet Baxter. Is Rethink Robotics. Flagship product in a revolutionary category of robot with common sense. Baxter is a low-cost and highly adaptive robot for manufacturing applications and is so easy to use that non-technical workers can train it. Baxter increases workforce productivity so that factories can compete with low-cost offshore labor. And Rethink Robotics practices what it preaches. Our robots are made in America. Uncrated and doing useful work in under an hour. Traditional manufacturing robots need to be programmed by expensive technical professionals. Baxter can be trained by non-technical personnel. Train Baxter to do a new task by just showing it what to do. No application software or teach patent is required. So the people working with Baxter get a promotion from working on repetitive mundane tasks to supervising robots that do them. Baxter has a suite of integrated sensors and the common sense to work intelligently. It adapts to the speed of the conveyor and variation in part placement and does human-scale tasks and human capability. So unlike traditional automation, there's no need to redesign your workflow to eliminate Baxter. Baxter safely operates elbow-to-elbow with people. Its unique compliant mechanical architecture lets Baxter give on contact. Baxter is an extensible platform like a PC or smartphone. You get regular software updates with new capabilities. Baxter is showing up everywhere at small manufacturing firms that couldn't previously afford robots, and at large firms rethinking processes that weren't previously economical to running. Rethink manufacturing, rethink offshoring, rethink robotics.
So what we just saw there was Baxter. Now Baxter is a deliberate attempt to compete against offshoring and to bring down the cost of labor, or bring down the cost of manufacturing by effectively removing labor from there. Now you will notice in the videos that they always talk about augmenting the workforce and taking away the manual tasks. Now, earlier this month, the second release of the software needed, and this is important because the developers and manufacturers of Rethink Robotics see effectively Baxter as being like an iPhone, where they have software releases being released that massively increase the capability of the product, but also other applications can be developed by by other companies to go on that operating system. And they've just released the second version of their operating system, which has dramatically increased the speed and the flexibility of Baxter, dramatically increased the capabilities of it. So, as technology develops in other areas, it's going to be applied to that operating platform. And one of the most, devastating impacts this is going to have is that the cost. Whereas before we talk about robotics as being a hugely expensive investment in terms of not just the robot itself, but also the ability to fit that in conjunction with the production lines and all the other equipment that you actually have. Baxter retails at $22,000, so that's about the same cost as one blue-collar worker. The difference is Baxter doesn't need holidays. He doesn't sleep. He works 24/7. He doesn't join unions. He doesn't get sick. He doesn't need a pension. And effectively, he never ever stops, and he learns and develops as the software develops and as people can program it. So, whereas to run 24/7, you would probably have to have 3 different people working 3 different shifts, and actually you'd have to cover for holidays and for maternities and leaves. Here we're now looking at robots that effectively can do these kind of tasks, you know, at a one-off cost, less than the cost of a single person. It's not just the US, though. This is not the only instances of this. I'd like to take you now to Japan.
Given Google's new self-driving cars, the increasing use of automated software to grade college essays, and the unmanned CIA drones striking targets in Pakistan, perhaps these robotic factory workers shouldn't come as such a surprise. The rise of the robots might terrify most, but here in Japan they're making a positive impression on their work colleagues. It's nice. It's like a human being. It's cute. Built by Kawada Industries, these humanoids alongside their Homo sapien brothers to manufacture ATMs and ticket machines. Known as next-age employees, they have been accepted as important, even inspirational members of the team. He works with more accuracy than us, but it motivates us. First constructed in Tokyo 5 years ago, not far from this factory, Next Age is an employer's dream. It has a fierce work ethic and shows no signs of fatigue. It can work around the clock for a period of 3 to 5 years with no holidays, and it is never sick. Next Age works tirelessly, accurately, and without complaint thanks to the specific computer code that it is DNA. In fact, it's not too complicated. We already have a blueprint for every movement. We just select these patterns and stream them from end to end. Whilst the robot's humanistic features are probably helping prompt orders, the fact that 30,000 euro fee can be recouped in just a few months is also part of the appeal.
So again, same sort of development taking place there. China is picked up on this big time, and you know, you're now looking at robots revolutionizing China's electronics manufacturing. So one of the companies that we saw earlier that was getting a lot of bad press was Foxconn because of the 17 suicides. And initially Foxconn's reaction to that was to build nets around the building, so if people jumped off, at least they landed in the nets. They're now taking a different approach. Foxconn's looking to replace pretty much its entire workforce with robots. It's currently placing an order for about 500,000 robots, which will take away 1 million jobs. And they're actually looking to extend that beyond that. And you can see from the headlines at the bottom there, they're looking to speed up this robot army deployment. So, you know, how to deal with the rising cost of running your factory? Well, let's get rid of all those inefficient humans and hire robots instead. And that seems to be the strategy for Foxconn. Now, we also have 3D printers. So technology is enabling, you know, new tools. So we see Nike there with their vapor laser talon tube, you know, with a sole that's completely developed on 3D printers. We've seen architects developing models using 3D printers. We've obviously had the bad press around the capability of using 3D printers to produce firearms, and even, you know, this Dieter von Dess modeling a dress that's made from a 3D printer. So again, this is creating new opportunities for machinery to develop things that previously were developed by human hands using new tools and techniques. Well, let's go to deliver. Now, earlier we saw, again, you know, a lot of bad press around the working conditions that were in places such as, you know, Amazon, and the fact that people were being treated like robots. So what's actually happening in the ability to store products and move products to customer? Well, let's take a look. And we'll start first by going to the US. Now, I don't know if any of you have seen these. These are called bots. And they're automating the way goods are picked, packed, and loaded in warehouses. And I'd like you to take a look at this, please.
Their formal name is robotic, but more affectionately known as the bot.
inventory could actually walk and stop. Station that's inside of a queuing system, and now it's being told by the host to take the load back to storage. What we ended up doing was just laying down a grid pattern of stickers on the floor, and we asked the robot to travel on those stickers. And so the robots are having a wireless conversation with the host directing the traffic. The inventory figures out where to store itself.
About 50,000 square feet of our warehouse is designated as Kiva storage location. We have over 300,000 units of inventory currently on the Kiva floor. This is one of our picking stations. The laser and the touchscreen is going to tell our associates here what units to pick and then what order that unit corresponds to. Each blue tote represents a customer order. So we're picking 17 customer orders simultaneously. The system is dynamic enough that it knows which SKUs are selling the most. So it keeps those pods close to where the action is. It keeps our associates productive during their entire shift, as opposed to spending 2/3 of their day walking aisles, seeking out customer units, or looking for empty locations to put away merchandise. They're right at their station with predictable output, and they're constantly working for us.
The starter kit for Kiva for a small .com retailer might be a $1 to $2 million two-station, couple hundred pods box. The sweet spot for our customers seems to be in the $4 million to $6 million range. That's a typical capital deployment. But then, of course, we're selling a lot in the 10 to 15, and we've got some customers with $20 million of Kiva equipment under one roof. The human here is very vital to the actual manipulation of the inventory. In the Kiva model, the human in the loop is very important. What we're trying to do is augment the human by eliminating all their wasted time and motion.
Just watching how they communicate with each other behind the scenes so that they're not crashing into each other is really something that's just overwhelming at first.
They're very fun to watch, and we're having a lot of fun as a company bringing this solution to the market.
So there we saw a complete reimagining of the way to run a warehouse where the inventory moves to the person rather than the person needs to move to the inventory. And actually what that's taken is it's taken 80 to 90% of the workforce out of the warehouse. So one of the things you would not have seen a lot of there is outside of the people stood at the picking stations, no one else is there. The inventory is moving itself alone around, and it's completely controlled by a computer. And as the gentleman said, you know, the system understands what are the fast-moving and slow-moving items and repositions itself. So it repositions the inventory automatically to ensure that the fast-moving goods are closest to the pickers, and actually so they don't have to travel quite so far. So this is, you know, a real intelligence around the algorithmic side of the equations that are being used to manage this, but also the complete reimagining of how to run a warehouse. And some of the benefits of the Kiva systems that they've announced are the fact that you don't need to redesign your warehouse. You just need to, you know, take a lot of the cages and stuff out so the bots can move around. There are elevators that allow the bots to move up and down between floors if you've got mezzanine floors, that sort of thing. And it's creating huge productivity improvements, but obviously huge changes to the number of people involved in the equation. Now, as I said earlier, one of the companies that were getting a lot of bad press was Amazon. And you would have seen there that one of the companies that used the system was Zappos.com. Now, Amazon, as some of you may know, purchased Zappos.com and other companies like Diapers.com a little while ago. And they saw this. And so what they did was they bought the company. So Amazon bought Kiva Systems last year for $775 million in cash. So, you know, Jeff Bezos, never been one to miss an opportunity, has seen that, you know, a lot of their issues are around people and about the management of people in these warehouses and all the labor issues and the bad press is coming around the management of people. this kind of gets rid of the people in the core of his operations, which is the warehouse. So they bought the company and are going to use it to create real competitive advantage from a cost perspective. Now let's go across to California. Now, I have a real regret with this particular image, because this is, this is Governor Brown signing off the use of the automated car that Google produced, the Google car, on their roads, the legalization of it. And my regret is that I really wish Arnold Schwarzenegger was still the governor of California and making that signature, because I just think the headlines that the Terminator, authorizes the use of robot cars on the road would have been brilliant. Let's have a look at them.
The witness for the first time on any screen.
Old visions of futuristic cars. First, cars that park themselves, and then
And now it's driving. It uses cameras inside for traffic lights and other things. It also uses this thing on the top, which is a scanning laser.
They say this car's already driven itself 100 itself? Really? Here's how it works. You tell the car your destination. It plots a route. It's aware of speed limits, traffic patterns, and known obstacles. So the wheel just turns completely by itself.
Completely by itself.
It's not intended to replace the button for auto drive when
to drive it, that's fine. If you wish to wait 52 minutes before new traffic, go ahead. You might get it.
In fact, Google touts safety as their motivation. They say this technology could one day cut traffic deaths in half. Whoa! Alternating turns with other cars. Walk ahead.
It would be the same probably with pedestrian safety, in the sense of using the radio signals to check and see who's in front of them, who's around.
But how does it handle the unexpected? How about a little game of chicken? It stopped, but I was really scared it wouldn't.
My hope is that we transform society to make traffic safer, more efficient, and also more pleasurable.
So automated cars on the roads now, and we're talking about the extension of these, as the legal system catches up with the ability to drive a car that ultimately someone isn't driving at this point in time. Now, you will have heard again and again throughout this that these are not designed to replace humans, these are designed to augment humans, and that's been said across a number of these factors. And you could believe that, but then suddenly you see headlines like this, where Google is actually saying, well, actually, we don't need drivers. Why don't we, have driverless taxis? So they're now planning to create driverless taxis to carry passengers around. So you're looking at, effectively, driving jobs, becoming redundant. No need to drive them. The vehicles can drive themselves using GPS technology and all of these, laser capabilities to be able to move themselves around. Now, just in the U.S. alone, 2.6% of the U.S. workforce, that's 5.6 million people, is involved in a driving job. It's going to raise some very interesting questions about, what do they do? But it's not just cars. We're also talking about the supply chain here, so it's about logistics. We're talking about trucks as well. So now I'm going to go to Barcelona, and this is from last year. This is Project Centric, and something called platooning or road train, and I'd like to show you this.
Request for joining. Platoon request accepted.
It looks like a normal truck with another truck and 3 passenger cars behind it. In fact, this is the first time ever that the Centric project tests a road train on a normal motorway in everyday traffic conditions.
I think it's really impressive. I think we spent the last 2.5 years developing a demonstrator, and to be able to get that out onto the public highway and show it how it actually works is really, really impressive. I'm very pleased.
And the advantages of a road train are many.
Convenience, since I can do something else than the actual driving.
safe, since the system will take care of the driving. It will eliminate the human error. And then fuel efficient, since we use a minor gas size between the vehicles, we will reduce air drag and thereby fuel consumption.
The aim of this test just outside Barcelona is to acquire more experience and knowledge about how a vehicle platoon in convoy, where a lead vehicle with a professional driver who both steers and wirelessly communicates with 4 vehicles behind him, actually works in practice in normal traffic amongst normal motorists. And it's easy to see the numerous advantages of not having to steer, accelerate, and brake yourself.
It's quite fun to see the passing vehicles. They're quite surprised seeing me not driving the car but reading the magazine. They will stand back and see, we're actually not driving.
The researchers want to find out how the drivers and passengers experience sitting in a car at 85 kilometers an hour when it's being controlled by somebody else.
I think it gets easier as time progresses and people become more familiar with the technology and they accept it more. I think as generations progress, they become more familiar with it and more accepting of it. Like my son, he's asking me questions about this. He wants to...
Sorry, that video cut short a little bit, I do apologise. That's platooning, so this is where a lead vehicle is driven by someone and all the other vehicles behind it effectively are communicating via Wi-Fi and are following that lead vehicle. Now, from a personal perspective, you know, one of the most frustrating things on the motorway is getting stuck behind a lorry, so personally volunteering to be stuck behind a lorry driving at 56 miles per hour is probably something I can't see myself wanting to do. But you can see the benefits from a logistics perspective of having a train of lorries lined up in a very small gap between them that is massively increasing the fuel efficiency and therefore decreasing the carbon emissions that are actually taking place. And actually, you know, having these road trains developed where effectively only the first one is doing the controlling, everything else is just following. And then you can also potentially imagine the collaboration between, different companies to use these road trains to move goods from point A to point B. So automation has had potentially a big impact here, and this technology exists. That was a real test on a real road. It's not something that's science fiction. It is science fact. But what about the consumer, and actually point in terms of the consumer, what's actually happening there? Well, again, let's go over to the Korea, for example. There's what you may be looking at here is, believe it or not, that person with a flat cap in the middle is actually boarding a train. That's a subway station, and this is Home Plus, which is Tesco's Korean company. And what people are doing there is they're placing orders using a virtual display of products on a subway station. And actually, Tesco's is guaranteeing that by the time you get home, your order will be there within 30 minutes of that arrival point. So what they've done is they've carefully segmented their product lines, created a virtual display of the products that people want, at a convenience basis, allowing them to purchase it using QR codes on their smartphones and then delivering directly to home. This is obviously changing the nature of customers. People aren't having to go to shops. They're not even having to go onto a website. They're doing it via virtual displays. And what Tesco's has established is that the biggest users of smartphones and the biggest adopters of this kind of technology are, unsurprisingly, the young. And therefore what they've done is, as well as subway stations, they've also taken over all of the bus stops around the Seoul's universities and actually put these virtual displays up there. Now, obviously, what they're not doing is offering all products. They've just carefully segmented the product lines to those things that people need on a day-to-day basis. So you'll see there fruit juices, milks, beverages, that sort of thing. Over in the US, here's two very innocent-looking vending machines, the Coke Freestyle machine and the Unilever Walls Share Happy machine. Now, these look like gimmicks, but what's actually going on here? Well, the Coke Freestyle machine, for example, offers 120 different beverages using pharmaceutical microdosing technologies. And what that's actually doing is, rather than just offering a wide variety of drinks, it's allowing the consumer to mix the drinks that they want, so they can pick from different ranges. Now, that sounds novel, but actually if you see beyond that, what's really happening is the consumer is requesting these particular vending machines, and actually restaurants that put these vending machines in are noticing a 100-point increase in sales. because consumers are going to where the vending machines are. The real benefit comes on really understanding consumer demand, because these machines communicate wirelessly back to their base, and they automatically replenish themselves. The stock inventory can be checked remotely. But also what Coca-Cola are able to do, they're able to understand what people like to drink and in what combination they like to drink it. And that machine knows exactly where it is. So if it's in, for example, Atlanta, in a Pizza Hut restaurant, and people like mixing Coke and Fanta, Coke understands immediately that there's a real marketing opportunity here to have a Coke Fanta mix for people who like pizza. Specifically if that same machine with those same options doesn't get used in the same way further up the coast in New York for example, a chicken restaurant. So it's really beginning to understand consumer demand and also be able to replenish itself. The Share Happy machine uses a very similar approach. It sounds, again, very, very twee. It's the ability to take a picture of yourself enjoying your Wall's ice cream. And that sounds just, a novel gimmick, and you can share it using social media via that machine. But what's Unilever really doing here? Well, it's taken a photo image of you. It knows what ice cream you've selected. It has a picture of you. It knows your authenticity. It knows where that machine is. Again, it replenishes itself. So it's getting to understand exactly who are our consumers and what do they want and where do they want it. This is creating real intelligence. It's also creating a huge amount of data, which has to be planned and has to feed into our plans. So this hasn't been possible up until now. It's only with the development of cloud computing and the ability to interrelate all of these previously dumb objects that we're able to do this. This enables us to use something that you weren't heard of called big data. So the ability to perform, complex analytics on huge amounts of information, which in itself creates, challenges. So let's have a look at some of those challenges. So big data creating big challenges and also big opportunities, and it's actually changing the nature of work once again. We need new talent, new jobs to be able to manage this data and to make sense of it. Once we've actually analyzed these demand signals, we can now pass it into our ERP systems, which again are now becoming, you don't need the same sort of server architecture. They can acquire the software as a service off the cloud. And we can use technology to do automatic replenishment, automatic production works orders, automatic purchase requisitions, which can be converted into automatic purchase orders sent to the supplier. So the supplier then automatically brings that stock back in to the warehouse. So we're starting to automate the entire nature of the end-to-end supply chain. And companies like SAP are using this technology. SAP has this HANA product. Other companies also have it live in memory data to analyze this ever-increasing volume of data and to make more agility and better decisions in the supply chain. So the robots are rising, and it says here headlines that were more than 160,000 industrial robots sold in 2012. In the United States continues to increase. Well, we've already seen, based on what Foxconn's doing, that this is going to explode. They're looking to have 500,000 robots by 2014, 2015. So this is going to dramatically explode as an industry. And many of you will be aware of Gordon Moore's law that that basically the number of transistors on circuits doubles approximately every 18 months to 2 years, and that this trend has continued. And they're predicting it to continue to at least 2020. So we see images like this where, we used to talk about computers being the size of a room, then it became obviously something that's on your desk. Now the size of something that used to sit on the desk now fits in your pocket. So this is the impact that Moore's law is actually having. But it's redefining the art of the possible. Now, I think this is a really great example. And we always talked about, yesterday's certainties being today's absurdities. And when we've talked about that, we've talked about a long passage of time taking place between the certainty and the absurdity. Take a look at this. This is the book called The New Division of Labor, written by two very eminent economists, Frank Levy and Richard Murnane from MIT and Harvard, who in 2004 published this book. And one of the things they made as a statement of fact was that truck driving was one of those things that just quite simply would not be able to be automated because there's just too many variables, there's too many moving parts. But we've already just seen a video where automated trucks are effectively on the road. So 2004, a statement of fact, you will not be able to do this. Already that's been proven to be absurd, and that we've actually got these. And Google had Google cars around 2010, so the gap between statement and absurdity was only 6 years. And that's incredible. And now we're moving to the Internet of Things. So we're now talking beyond, talking about mechanics and computers. We're now talking about connecting everything together. So we're moving to the Internet of Things, where previously dumb objects like vending machines are starting to transmit data over high-speed networks. And talking about machine-to-machine communication, so robots communicating with robots. So we talk now about the evolution, where we're moving from the world being an index through the computers taking control of the world, talking to each other, and becoming intelligent. And now the thing is, the Internet of Things is moving to the Internet of Everything. And Cisco is doing some really great work here, and I've seen a great presentation only 2 weeks ago by Cisco that, looking at the value proposition of connecting pretty much everything, people, processes, data, objects together, using the internet, using the cloud to enable objects to interrelate and dramatically increase the number of connections. So we have our.
Sean, I just wanted to add one note that we are about at the end of our scheduled time. I think we can go ahead and keep going. I just wanted to note, if for people that do have to leave because of their schedules, thank you for being here, and we will post the entire recording for what you'll miss.
Yeah, apologies for running over. I will be finished soon. Nope. Thanks, Melinda.
Okay.
So we're now moving from a world where we saw this, where the automated warehouse have Autobots bring stock to a human to actually pick. But how long before they say, well, the weak link in this chain is the human, so why don't we get a Baxter equivalent to do the picking? And how long before the Baxters of the world start making each other? And how long before, hey, they start replacing more than just warehousing activities? In fact, they're even talking. They're now having robot football competitions, and this was I wanted to show the video, but there's a really interesting clip here where they're actually saying, we've got competitions at the moment with robots playing football, which at the moment look quite clunky, but one of the things they're able to do is communicate with each other. Non-verbally, the robots know what each other are thinking and actually to move into positions, and things that, you can't do at the moment. And I cracked the joke when I delivered this in Frankfurt that, as an Englishman, we've always said the German football team plays like robots, and unfortunately the English team play like broken robots. So we're looking at a future supply chain. Is it a human-free zone? All of these elements that we've just seen on that particular map there, we've just seen examples of where basically people are being phased out of the equation. One of the certain big impacts it's likely to have is on the whole offshoring movement. So previously we were moving manufacturing and offshore because we were chasing low-cost labor. But manufacturing is now starting to come back, and we're starting to talk about reshoring. There's this headline here says, manufacturing is back, but where are the jobs? And a really interesting statistic here is that the US produces a quarter more goods and services today than it did in 1999, but using almost precisely the same number of workers. So the statement here is brilliant. It said it's as if the $2.5 trillion worth of stuff, or the equivalent of the entire United States economy in 1958, simply materialized out of thin air. Although, and again, the line underneath it, although businesses haven't added many people, they've certainly bulked up on machines. Now, there's a clip you can find on YouTube of the CEO of Baxter, Rethink Robotics, saying, hey, at the moment we're using this to try and automate the factory line, but flipping burgers, pouring coffee, the service industry, that's not so difficult. We can certainly use this kind of technology in the service industry to do a lot of, again, very automated jobs. So from supplier to the person who serves the customer's customer, we're looking at a world where all of these workers effectively are not required. And what's the impact of that? When everyone effectively in those kind of environments are replaced by robots. So are we going to see sort of headlines like this, where people start to ask, Daddy, what was a truck driver? Because effectively driving is not something you do. It's something that you're a participant of. And maybe you're sitting there thinking, this is all very interesting and maybe a little bit scary, but it's not going to affect me. Well, think again. Because the number of jobs that aren't going to be affected by this, are really, really shrinking. That there's a number of different jobs here. There's jobs that we can only do at the moment, but machines will do better. There are jobs that only humans will be able to do for a while. There are current jobs that humans can't do, but machines will be able to do. So a whole new factor. And they're talking about, for example, the Fukushima nuclear plant, that robots being able to go in and do work that's too dangerous for humans. And there are jobs that we can't even imagine yet. And Mani Suprani, professor of Carlson School, saying the set of jobs that won't someday be done by robots is actually rather small and shrinking as technology and therefore Moore's law advances. And this is having an impact, and it's having an impact already. And this is from a couple of years ago, but headlines saying unskilled workers are struggling to keep up with technological change. So as technology increases, the vast majority of the world's workforce is unskilled, and it's been looking at globalization as a way to create employment for them. The question is it going to happen? And in fact, it's having an impact. So, Jim O'Neill from Goldman Sachs, who came up with the title of BRIC, Brazil, Russia, India, China, says basically only China is the country that's currently worth the title, because the other countries effectively have major impacts, and technology advances is playing a big part in this, as well as obviously social factors such as in Brazil, which has another socioeconomic impact, because we've seen that the workforce of these emerging countries becoming motivated about the potential that's being created, and that actually they want to be consumers of products, not just manufacturers of it. And headlines like this, the death of unskilled labor, labor in South Africa is too expensive for the country. It's India tomorrow heading for disaster because people are unskilled, unemployed, and angry. At the top there, India's key to future success, its youth, is a ticking time bomb. It's a growing mass of largely undernourished, undereducated, unemployable young people who aspire for a better life but don't have the means to get there. Why? Because they aren't qualified for the job market, and even if they are, the jobs don't exist. And this is only going to increase. These headlines, all recent headlines, are saying, Obama must face the rise of the robots. So President Obama in the States is saying, basically technology will leave a large chunk of the U.S. labor force in the lurch. So it's not just the emerging countries, but also developed ones as well. To the point that some people are quoting that, the vast majority of what we define as work right now will be automated by 2045. But what's the impact of this? Well, Voltaire once said that, work saves us from three great evils: boredom, vice, and need. And a recent study by Jim Clifton, who was the CEO and chairman of Gallup, did a worldwide study, a 5-year worldwide study, which was published in a book called The Coming Jobs War, found that the major driving force behind most people worldwide is the need and desire for a good job. So we're going back to Maslow's hierarchy of needs here. We're looking to be able to cover the bases in terms of security and food and health, but actually moving towards self-actualization, a job that means something to them. And what he's saying is actually these jobs are going to decrease in number, and there is going to be a global jobs war. What Jim says in his book is that if countries fail at creating these jobs, their societies will fall apart. Countries, and more specifically cities, will experience suffering, instability, chaos, and eventually revolution. Now, this might sound overly dramatic, and you might sit there thinking this is just dramatism, but let's look at what that would look like if a city failed in ability to create jobs. It might look a bit like this. This is Detroit, which was the heart of the first automation revolution, but is now bankrupt at the start of the second. But what about this? So we replace human workers with robot workers. But unlike humans, robots don't have to earn money for a purpose. They don't spend money. They don't generate income. So there's nothing to tax. So where does the revenue come from? Tax revenue that used to come from people's income to pay for all of this. What do about this? Should we be formed like the Luddites? Should we break the machines? Well, not according to some people. So here's a piece of work by Federico Castonio, who says, listen, this is going to happen. Robots will steal your job, but that's okay. It's a natural evolution of things. We are not meant to be beasts of burden. We are not meant to pick things out of the ground with our hands, and we're not meant to work our minds. We will use machinery to do this, and we will evolve to a better job. And we've been here before. So 200 years ago, 70% of American workers lived on a farm, but now automation's pretty much taken all of them out. We used to have jobs like this, sweepers and doffers, that just don't exist anymore. So what I'm saying is, we've been here before. This has happened before. And hey, we might even get a nice T-shirt this time around. So maybe the future is that the death of I-shaped people, so people who just have, one skill set, a very functional focus, that will become automated. So what we need instead is the T-shaped people that we've talked about, people who understand the end-to-end value chain, understand the customer, and can think beyond a single specialization and actually be much more creative. So maybe the future is right brain, not left brain. Maybe all the things on the left are going to be automated and actually allow people to be more creative, to do more innovative things, and that's where the future lies. So maybe we're featuring the 7 stages of robot replacement, where we start off with thinking that maybe a robot or computer cannot possibly do what we do now, and then find out they can do some of the things, but not everything. And then maybe we think, well, okay, maybe it can do everything, but when it breaks down, I have to mend it, and to the point where it doesn't break down and doesn't need mending. So then suddenly you give up your old job, but do something new and new, exciting, that's more fun and pays more. And then just hope that someday the computer isn't able to do that as well. So I have 3 big questions I'd like to leave you with about what this actually means and where this is going, because this is going to happen. This is not an if or a maybe. It's a how soon is this going to happen. And here's 3 big questions. So question 1 is, what does this actually mean for the global supply chain? Does the rules of the game changing forever? What does it mean for offshoring? You know, how important is low-cost labor if we don't need labor? Will we change the source and will we become much more strategic about manufacturing and manufacturing closer to the customer so we don't have to spend so much on distribution? Will the labor war be finished off by robots? Will we continue to use China, but not for its people, for its robots? You're looking much more at resourcing. These are some really big questions about what this means and the impact it's going to have on the global supply chain. But one of the burning questions is the warehouse, the truck, the factory, the land. This was where an honest guy could used to go to earn an honest living, or an honest woman. What happens to them? Because this isn't the same before. Before jobs were eradicated and new jobs were created. This isn't the same. This is jobs being eradicated because it's being replaced by something else that does it for you. There are new jobs being created, but not everyone's going to have the skills. You know, the vast majority of people at the moment are unskilled or semi-skilled workers. Where did they go? What did they do? The 5.6 million people who are currently just in the States employed in the driving job are replaced. What do they do instead? Not everyone has the deep analytical skills or the mathematical skills or the creative skills needed. So there will be a war for those jobs, but what happens to everybody else? And finally, the big question I want to leave you for is, because this is going to happen, are you ready for it? Is your business under control? Because automation at the end of the day cannot replace things that are out of control. How much do you have to intervene in your current supply chain in order to get plans and schedules that are accurate? How much human intervention is there because there is a lack of clarity of ownership and responsibility? What would happen if your competitor could utilize this technology, make and produce and move stuff 24/7 without having to deal with unions, without having to deal with, you know, holidays and sick leave and all of the other costs that you have to put up for? Is the gulf in performance so much that effectively you'll be priced out of business? And what use is big data if you can't even control the small amount of data you've got in your business right now? So let's go back to Moore's law and look at where it's going. So they're saying by 2015 processing power transistors will surpass the brain power of a mouse. So okay, I'm not so scared at the moment the threat posed by a rodent. However, by 2023, they think they'll be able to surpass the brain power of a human. My question, of course, therefore, depends on what human. But by 2045, these transistors will be able to surpass the brain power equivalent to that of all human brains combined. Now, I don't know about you, but I'm sure I've seen a film a bit like that. I'd like to leave you there with those 3 big questions. Also, if you're interested in finding a little more, this was the original article that I wrote for the European Business Review. And Melinda, I'm sure we can make that available for anyone who's interested, or they can reach out to me personally at either of these 2 email addresses, either my Supply Chain Council email address or at my personal email address there. I do apologize profusely, a little bit of a late start did make me a little late, and I have overrun a little bit. So thank you for your attention, and I hope you found that interesting, informative, and maybe a little bit scary as well. Thank you.
Thank you, Sean. I just had a couple of comments from people that I can share. I had a question if we could post the links to the videos. So I don't know. I'll leave you to maybe answer that later. Okay. Just because several of them we couldn't hear. And also, I just had a comment from somebody, and I'm not sure what the IET is. I think it's something with European transportation. Anyway, I'm not sure what that acronym stands for, but it says the IET had a recent discussion about the pros and cons of driverless cars and the transition to a mix of driver and driverless cars will be fraught with risks that the lawyers will lap up. So, I've got some comments like that happening because of the fear that all these things create. But other than that, I just have compliments about.
Compliments are good, Melinda?
Yes. Compliments.
That was an interesting question about the legality, and I think that certainly with driverless cars and that particular autonomous vehicles, the technology it's there now. You saw in those of you who could pick up the example that it's a variety of different conditions. It can handle stop signs. It can handle junctions. The technology, it's the legality of having a car that isn't effectively in control by a human being that is there. So I do totally agree with that. But it's going to happen.
Yeah.
It's just going to take time.
Okay, and so that's really all I have. I think we're done. And thank you, Sean, for sharing and working through all the
Thank you. I hope the videos, for those who are still on the line, if you imagine what we're trying to achieve here, I'm running videos, of a presentation on my laptop that we're trying to broadcast across the world. There was, the lag in sound and stuff. I do apologize if there was a lag between the image and sound, but I hope they came across okay. I hope you could hear them fine. I will. We'll send out links to the presentation so people can actually see those. So if they want to reach out to me, I'm quite happy to do that. Or we can put that on the website. They're all from YouTube, as you probably guessed. So they're all freely available videos. And I revised this presentation quite a bit because the speed at which change is happening, the speed at which technology is happening, there's always new examples of this automation becoming available. But I'm more than willing to share whatever I've got with anyone.
Okay, thank you. And also, actually, this recording will be on YouTube also because the council has our own YouTube page now. So
brilliant.
Yeah, so we'll be YouTubing everything. Okay, thank you everyone for listening and participating today, and thank you, Sean. And good day, good evening, good morning to everyone around the world who's participated today.
Thank you very much, everyone. Bye-bye.
Thank you. Bye.